Okay, now we're recording. All right, so simulate, yes.
Any of the gauge of wire we can use?
Yeah, for this it doesn't really matter. Yeah. In the field, it definitely would, really only for the outputs, the relays, because those will be carrying power. But for our inputs, our data lines, it's not important. But for now, yeah, any strain will wire or will work. You could even use solid core or stranded core, it doesn't really matter. Things that do matter, okay, is that we have a good ground connection between our board right here, this G and D. You can use either one. They're actually bonded by metal. There's a strip of metal that binds these two and these two, okay? So you could go to either one and they're effectively in parallel, okay? You could also power something else, right? So if I had 24 volts, okay, actually I'm getting ahead of myself. So the way that our system, even the way that our PLC is powered, okay, is through this outlet right here, this DC barrel jack, okay? If we don't power our PLC with this DC barrel jack, we can still program it, LEDs will still turn on, we can still use our user button, but the the relays won't throw, okay? We won't actually make the relays move when we turn on ones and zeros. We need the 24 volt power, okay? That's why you guys have a barrel jack, right? A wall wart power adapter, is because we need that to work with our PLC. We just haven't had to use it yet. Okay. So what this is a passive breakout, which means that when we attach power to this, right, the center terminal here, the shiny silver, is where the positive 24 volts DC goes. On the inside there, on the bottom, you see that silver tongue. That goes on the outside of the barrel, which is typically negative, right? That's our ground connection. Okay, that connects, goes through this protection diode so we don't accidentally wire it backwards, but essentially you can see this copper trace. It's just a copper wire that goes from this connector to this pin. Okay, raw 24 volts that we're getting out of that wall wart, okay? So this effectively becomes our kind of like 24 volt breakout power supply that we can use to power things. Okay, we'll use it to power our heater board, we'll use it to power our PLC. If you really wanted to, you could break it out and power whatever, right? It's just attached to our power supply, effectively. So, in order to power our PLC, we need to go 24 volts here to 24 volts here or here. It's the same thing. These two pluses are bound together. They're connected with a piece of metal. It does not matter which one you attach to. Same with these negatives here. This is the ground input, okay? Right here is showing us that this PLC will accept anything between 12 and 24 volts and it will work, okay? So you can give it a 12 volt, you can give it an 18 volt, and it would work just fine, okay? I believe we're using 24 volt DC power supplies today, so this is great, right? Don't worry about anything else. Okay, see this ground up here? Don't let this confuse you. We are not using this ground. Same for this earth terminal. We are not using this earth terminal. Okay, that's a safety feature. It's not actually grounded to this negative terminal up here. Okay, so if you connect to this, you go, why is my circuit not working? It's because you're not actually grounded. Okay. So 24 to 24, or to plus, ground to minus. When you plug in this barrel jack, and even if you don't have this connected to USB, you'll see it fire up. Okay, LEDs will blink, your program will run if you have one on there, all that good stuff. Okay, so that is effectively how we install this in the field too. Okay, so inside of a cabinet or whatever this thing is being installed into, we'll typically have a DIN mounted power supply. Okay, it looks like this. Okay. So some cabinets will have actual outlets in them, others will just have a live rail that you patch into, right? You take a neutral, you take a positive, live, and then you put it into this power supply. Okay, just like our PLC, it has, see this rail connection? So they just slot right on there and they sit nice next to each other. So this is where we would get our, see this DC 24 volts power from. So positive to plus, negative to negative, and then this would power the PLC inside of the cabinet. Okay, you could still attach a USB to it to program it and talk to it and all that good stuff, but good things to know, right? Any questions so far? All good? All right. So, more things to know. Each one of these, oops, sorry, I'll zoom in. All right. So once this board is powered, something else cool will happen is that whenever you flick each of these up, these LEDs will show you that state. These LEDs will turn on too. Okay, kind of a nice visual feedback. Each of these switches obviously corresponds to each of these outputs. Okay, so the output of this terminal will be 0 volts. Okay, I could read it with a multimeter if I really wanted to. Okay, with the switch down, and 24 volts with the switch up, or 10 volts. I think there's a resistive divider on here. Okay, high, logic low. Okay, actual output. Again, on this terminal, I could read it with a multimeter and it would read voltage high. Okay, so what we have to do is we have to wire each individual wire from one of these terminals into one of our inputs up here, right? Making careful wiring that switch 1 goes to I1. You know, you could correct it in programming if you really wanted to, but it's kind of confusing that way. Okay. I've talked a little while now. Anyone have any questions? Anyone like super ready? Everything wiring is done and we're ready to move on. Okay, good to go? Okay. Sorry? What did you say?
I'm still trying to wire it.
Okay, that's fine. So for you guys that are done, what I'd like you to do is to go back to our previous lab and implement a kind of a new, just mini lab that uses what we did before with the user button, but flipping the switch instead, using our simulator board. That should give you enough time for the rest of these guys to catch up for wiring, and then we'll all come together as a group for the next one, okay? Yeah, any questions? You've got wires hanging out of there. Remember, you can't let it fray. So here, let me show you.
How do I fix it? How do I fix it?
So you just kind of pull it together like that. Okay. Using more in your your fingerprints, the friction in your fingerprints that draws the strands together. And then as you pull, you twist. So I'm twisting the wire as I'm pulling it through my fingers. And then it's nice and smart. Alright, so yeah, just go like that and then let me know if you want me to look at it, okay?
How do I get it to go to the ladder logic?
Oh, sure. So, right click on project. Sorry. Add. Make sure you can find it really fast. Yeah. Any other questions? Everyone okay? All right. I'll leave you to it.